Welcome to the YourTown television program. My name's Jeff Kline. I'm your host for the Naval Postgraduate School Foundation segment of the YourTown television program, where we bring you interesting faculty and students and what we're doing at NPS. This segment, we are talking to Dr. Alex Bordetsky, who is a professor in the Information Sciences Department. He is also the director of the Center for Network Innovation and Experimentation, or CENETIX. Is that right, Alex? And welcome to the show.
It's great to be in here.
Well, one of the ways I like to start off each segment is to find out a little bit about more of the people. So tell me, how did you come about coming to the Naval Postgraduate School?
I was already enjoying the fruits of having tenure in a different university on the East Bay and running the telecommunications center. Starting working with Lawrence Livermore Lab, got invited by Professor Robert Twiggs to join his team at Stanford Space Systems Development Lab.
Oh.
And yes, as you know, he's a father of CubeSat.
Oh, yes.
Movement.
Well, CubeSat, we'll have to explain to our audience, those are very small satellites, is that right? That go up when we need to and have them orbit the Earth. But go ahead.
And exactly at that time, the Aerospace Corporation built first CubeSats, the size of the T-plate.
Right.
And student teams operated it. It was a fascinating project. So I started to look around for something more interesting that I had in the
more interesting than
no, not in Stanford, in the Center of Telecommunications at Cal State East Bay, where I was before that. And one of my colleagues, the chief editor of Telecommunication Systems Journal and Electronic Commerce, Professor Bezalel Gavish, suggested me to look at the Naval Postgraduate School.
Oh.
Currently conducting the search. So I knew people had a tremendous respect to the place. Professor Dan Dolk, now emeritus, Professor Rick Rosenthal.
Sure, Rick Rosenthal, sure.
Yeah, and so I applied, I made it, and I am at the Naval Postgraduate School since, enjoying the unique environment and great adventures.
Well, now, you talk about telecommunication. Is that what your actual doctorate is in? What is your doctorate in?
The doctorate was more, not exactly, not on telecommunications. That came up later. My doctorate was in decision support systems.
Right.
In particular in group decision support.
Oh. So more like command and control type things and in large areas, sure.
Which actually brought me into command and control domain when I was already working at the University of Texas at Dallas. Got the first grant at the Air Force, with the Air Force, at Wright-Patterson, and that brought me in the world of command and control, where we met putting together the first experiment.
Oh, sure. Well, I want to talk about that one a little bit later on.
With Professor Bill Campbell.
Oh, yes, that was a great story, and I have one on that one. But let's talk a little bit about your center first, the Center for Network Innovation and Experimentation. What exactly why did you create that center, and what do you focus on?
We created it in 2004 to become the NPS hub for conducting applied research, an elaborate, comprehensive applied research with all kinds of networks, primarily to help build the field experimentation environment at NPS.
Right.
And among those networks, not only to study it as a subject, enterprise networks, tactical networks, social networks were not known back then in 2004, but the collaborative technologies and geographically distributed collaboration took the stage. So supporting of all these new environments, and at the same time, help to put the lab in the field.
Oh, right.
Which is basically to build a test bed, in the core of which is a research network.
Well, this is an important point that I want to underscore, is your center is critical on taking lessons and theory from the classroom to the lab, from the lab to the field. And now that gets me to my favorite Alex Bordetsky story that I have to tell. In the experiment that we conducted, it was 2002 time frame, I think. I was just reporting to postgraduate school as a Navy captain, and we were doing an experiment that had to do with command and control of a tactical situation, but remote command and control, so that the command and control was actually being held in Norfolk, Virginia, while we were running a tactical exercise on the campus itself. That was the idea. But I witnessed you inventing new things faster than we could actually conduct or plan the experiment. And so the most challenging and fun part about that experience was watching Dr. Alex Bordetsky invent something new thing for the network before we'd even test the old thing that you had last invented. And the speed of that was unbelievable. Now, a lot of great things came from that experiment, not only the remote capability. It was a success, I remember that quite well, but also the entire concept of a network operations center. It's how important it is to control those aspects. But since that time, tell us a little bit of the things that you've been into and the field experimentation, the things you've taken out of the lab and taken to the field, which is so critical for our officer-student population.
Jeff, thank you for such a nice, summary of the 2002 experiment. In fact, if I may, I would like to highlight that it is because of that experiment that Professor Dave Netzer, our VP for research back then, came by and asked us, can we do the same, which you did with Dr. Campbell and Captain Kline, but modify to the needs of the Special Operations Command and start something we didn't have before at school, named field experimentation.
Right.
And that's the role of 2002 experiment we were in.
Well, in fact, we should underscore that our field experimentation program now at the Naval Postgraduate School is huge and involves both industry, different defense entities, as well as our own faculty and students. So that genesis of that one exercise 17 years ago now was really kicked that one off, which is fantastic. So but as our field experimentation program grew, your center was participating in that at all the time. What were the different things you looked at as we grew that experimentation program?
First of all, we created the test bed.
The test bed, right.
Very unique research network spanning out of NPS campus through 7 hilltops to the Camp Roberts, and expanding in Camp Roberts to different sites with all kinds of unmanned systems.
Well, before you go farther, we should tell our audience that those hilltop sensors allowed us to network all the way from Camp Roberts back to the Naval Postgraduate School. So there was a large part of California that we networked just for this experimentation program.
Correct.
Okay, go ahead.
And until 4 years ago, we actually had it up and running. Long, basically more than 10 years. So, answering your question on the evolution, so it became a campaign known TNT, Tactical Networking Topology and Testbed.
Tactical Network Topology Testbed.
Which we were doing successfully with SOCOM. Then between 2005 to 2007, Lawrence Livermore Lab came up front and brought the counter WMD maritime dimension.
So counter WMD is weapons of mass destruction.
Right.
Are actually looking for nuclear weapons, proliferation, counter-proliferation.
Small craft threat, small quantities, transfer, something elusive to work with, but happening in the maritime domain. And we've established the branch of TNT named TNT MEO, Maritime Interdiction Operations.
Now, this was a worldwide exercise. Is that right?
Which later on evolved, and
Oh,
then
okay. I'm sorry, you're starting with...
it existed as two branches.
Right.
Then around 2009, Professor Netzer retired. My colleague, Dr. Ray Bittner, took the lead on the field experimentation on the whole. The TNT transformed into GFIX, Joint Interagency Field Experimentation,
Right.
Under his leadership. And the maritime interdiction operations continue to exist and unfolded into the international, which it was almost from the beginning. Right. But between 2010 and 2014, it was in many ways an international experimentation with our colleagues, so we can learn together how to protect maritime borders and transfer situational awareness on the threat transfer. And
so this was a fascinating worldwide exercise that I want to cover just a little bit more in detail. You started off with maritime interdiction operations for potentially WMD challenges coming into the Middle California. But then we expanded that to worldwide, and we told the story of where that equipment came from and where the land in Central Europe that we then employed some of the networks and sensors that you set up to try to stop the WMD, and how it came across the world in different countries that participated. So tell us a little bit about that story, starting with the origin of the nuclear material to the different countries that participated in this exercise as it came all the way back to California.
Now, we had different global scenarios,
right,
as you described, playing it together with our colleagues. One of the, in 2008, 2009, looking back a little bit, it was one of the most globalized scenarios, inspired by the DNDO international program,
right,
model, so that beginning Southern Europe, illicit material is transferred through the borders on the way to the Baltic area. So in which case we played both red team and blue team in that scenario. With help of our Swedish colleagues,
right,
we've modeled the transfer and our ability to maintain some level of awareness of tracking that this is actually going on the ferry to Karlskrona, Sweden, with Swedish Navy conducting an interdiction, missing the target. The target got in Gothenburg into the other large cargo ship on the way to the United States. Then a couple of months later, yes, it was a break. We couldn't play it all together. But with that level of simplification, the next round with Port Authority, New York, New Jersey,
right,
it was a fascinating experience, us going through the Holland Tunnel and
working with them in order
working with their Coast Guard, Marine Police in both New Jersey and New York Harbor. It was a great experimentation. Multiple lessons came out of it, and our ability to quickly deploy networks with sensors,
right,
collect information, and also bring the remote experts into an immediate real-time response. That was our joint accomplishment with the Lawrence Livermore Lab, that what lasted hours before was done in a few minutes.
So let's bring a little bit of this. We have a video I want to play. And this one talks about, shows actually something called a Throwbot, which is a robot that a maritime interdiction operation or team could use to throw on top in different areas, remotely drive it around to do both survey work, optical survey work, and potentially survey work, sensor work as well. And it's all tied together in a tactical network. So we see someone throwing a robot on top of a ship and steering it around with electro-optics. Is he the only one who can see from that robot, or is that networked somewhere else?
It's networked somewhere else.
Okay.
At the beginning, it started exactly like you described, but the goal for the experiment was to put it on the network and make it viewed by the Mobile Operations Center,
right,
either on the Coast Guard cutter, some distance away from the boarding team conducting the search,
right,
or in the center ashore, which in our current experiments is now migrating to the special forces techniques named Remote Advise and Assist, when
Right.
you have local centers. And through those centers, also viewed by the subject matter experts far away in their offices running computational models associated with the findings of those robotic elements or the feedback from the operator.
Right. Now, on the video, we're seeing both a small Throwbot, we're also seeing a larger robot that has the capability of going upstairs and that sort of thing with those sensors. And all that's kludged and networked off, just not for the boarding team, but for a central operating system that can use that information and fuse that information in order for intercept. And that was really just the MIO, but you expanded that to both land and sea and everything else. That's great. So tell us, what is the current exercises that you're doing, and what do they involve?
It's a natural evolution.
Right.
Some of the things that we are now practicing is heavy involvement of special forces techniques, because the findings of the illicit material may happen accidentally, and how do we bring meticulously structured operation to the environment where things are ad hoc and not always have right people on the side of action, right in terms of technology and findings. So how do we bring, by means of networking, the collective mind, largely distributed, into the support of that activity?
So a tactical action that is supported by many different places.
Right. Yeah, by expert knowledge of the remote participants and robotics of different kind unmanned systems, helping locally to quickly search, to protect, like the Throwbots that you referred to. What is their role? Well, it's a hostile environment when the boarding team is busy to stay safe in face of hostility on the board of the vessel. So they have no time to go about every corner. The Throwbots provide that vital complementary awareness on what is happening around. The larger UGVs are carrying on those little ones in their grippers and helping to spread it, as well as to move network around, and that goes on and on.
So let's shift a little bit from that. Most of that security work, and a very important security work, you're also working with something called, they're mesh networks, and thinking about the security of ships at sea during conflict. Essentially, a Navy ship, if it communicates like we do now, it can be intercepted, it can be targeted by a potential adversary. But you're coming up with ideas for mesh networks where there's short nodal transmissions, different parts can be nodes at times, very confusing for someone to intercept, very confusing for someone to actually target the host platform. So can you tell us a little bit about that?
Yeah, that's the new paradigm, new concept that we're exploring, tentatively named short-living nodes and links. So we are migrating from the concept of the continuum of communication to the ones that are highly discrete in time and space. Yes.
And this is where we're pushing the boundaries.
We're pushing the boundaries. We basically are shooting the network out in literal terms of it. For example, projectile-based nodes, living only 20, 40 seconds in the air.
So shooting a gun round that is actually a communication node to quickly do a burst transmission and to support the node
collecting
itself.
Data, relaying it further, and conducting all regular mesh networking, or in more philosophical terms, self-organizing networking. But by the time we are, it's very short-living.
Right. But it's important because it actually establishes.
Yeah, but the information flows are going on.
Right.
That's why we are in the new world of security.
Well, Alex Bordetsky, thank you very much for the work you're doing. Keep inventing things and keep it inventing so we can field it, both experiment with it and then provide it out for our forces for stronger national defense. Thank you for being part of the show. And thank you for being part of the segment here for the Naval Postgraduate Foundation segment of the YourTown television program. We look forward to another segment with interesting faculty and students, and please join us.